What to make
Okay, good afternoon all the student friends. So at the outset, I welcome you to the fifth day of the online voting classes, and it's a good response yesterday. Today I will be discussing about network theorems. So before that, today's lecture plan is for about one and a half hour I will be discussing about network theorems. But remaining half an hour I would like to discuss about the question and answers. Okay, so so network theorems essentially it's not a classification. These are the theorems that are being available. Superposition theorem, network theorem, superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, reciprocity theorem, substitution theorem, compensation theorem, Millman, not Milliman, Millman, M-I-L-L-M-A-N-N. Okay, that is other's name, so you have to write it correctly. Millman's theorem, then Tilligen's theorem. So these are the 9 theorems are there. To my surprise, I found only the first 4 theorems are there in the gate syllabus. But does not matter that, does not mean that only those 4 theorems are applicable. No. I would like to discuss the remaining things also. But I want to cover some good example because very network theorems, as I mentioned in my initial remarks in electrical circuit subject introduction, electrical circuits is heart of the electrical engineering subjects. And network theorems is heart of electrical circuits. That is why I feel. So it's the most important topic. So that is why I want to explain in more detail. So I may split each theorem independently and problem solving also separately. So that is maybe if I can cover 4 theorems, it is okay. Otherwise, I will cover 2 or 3 theorems today. And because I have prepared for 4 theorems in today's lecture, followed by question and answers. And up to 1 and a half hour, whatever the time I can take for you for the theorems explanation, I will do. Rest I will do it for tomorrow's class. Okay, because these 4 are very, very fundamentally being explicitly mentioned in the gate syllabus. I will discuss, but nevertheless, they are also equally important. Okay, the other ones most of the times we use in Millman's theorem, we will use in power system applications also. Similarly, reciprocity theorem, electrical and electronics students will be using. Substitution theorem and compensation theorem, of course, we use most often. Compensation theorem, to understand, substitution theorem is required. Anyway, so this is only just introduction of the network theorems. And some people call loop current and nodal analysis also as a prerequisite in the graph theory subject, which I have mentioned in yesterday's lecture, which I will answer at the end, not the end, around 4:30 I will start. So that remaining half an hour I will spend time for questioning and question and answer session. Okay, already you have sent the questions through the Google form. I have received that and I prepared the answers also. But I could not prepare for the third one because I thought the graph theory is more critical because that's a relatively new topic for you, and so that's why I thought I will answer that first. So maybe some other day I will discuss unit 3, right? That is resonance. I will discuss the question and answers at next. So this is the brief introduction of today's lecture preparation. Now I will start with more formally about the superposition theorem. So in any two-terminal, linear, passive, bilateral electric circuit consisting of 2 or more sources, the current flown through any element can be obtained as the algebraic sum of the currents produced by each source acting alone. Not each sources, each source acting alone, when all other voltage sources are replaced by their internal resistances. So this can be more generalized also by replacing all other sources, simply sources, maybe voltage source or current sources. Okay, so I repeat the statement of the problem. in any two-terminal linear, passive, bilateral electric circuit, these things I have explained already. What is the linear, passive, bilateral already I have been mentioning in earlier lectures also. So electric circuit can be synonymously replaced with network, electrical network. I will answer the question that is raised also. Circuit and networks are being synonymously being used. I already informed you also. So consisting of two or more voltage sources or two or more sources. The question again will be asked me dependent voltage or independent voltage or current sources. They are independent, right? Okay. So any element can be obtained as the algebraic current flowing through any element can be obtained as the algebraic sum of currents produced by each source acting alone when all the sources are replaced by their internal resistances. Now, what is by internal resistance for each source? Okay, these are the DC ideal voltage sources. Let us say ideal voltage source is 0, short circuit. Practical voltage source is its internal resistance in series with that, right? And ideal current source is open circuit, that is infinite resistance. Practical current source is shunt resistance. That is how we get in source transformation also. That is how the voltage source and its series resistance is converted to ideal current, the current source, practical current source with shunt resistance. That is itself is the source transformation. You will be understanding source transformation issue subsequently in Thevenin's and Norton's theorems also, which I am going to discuss as the second theorems today itself probably. Yeah. Now, this is with respect to DC I mentioned, RI. Of course, now I got the idea to explain about the AC sources. Ideal voltage source, of course, is 0. It is short circuit to be replaced with internal impedances. Practical voltage source is to be represented with Z resistance or Thevenin, or simply in machine theory, if it is synchronous machine, synchronous impedance, because it is alternator, synchronous impedance. So, or other reactant or impedance. It depends on the type of the sealant pole or cylindrical machine you are finding ZS or so many things. That anyway will be deviated because in the first year level or if it is taught, it is a different issue. But it is third and fourth year level, I can give you in a broad way. And ideal current source is again open circuit is infinite impedance. Practical current source is shunt impedance in parallel with the corresponding one. So although in first year level perhaps this might not have been told in the first day itself with the superposition theorem that is being mentioned with internal resistance. First we will mention about DC, then of course AC also at a later stage. Okay. So anyway, now I have mentioned with AC source also, instead of resistance we will take just impedance. That is important. The rest of the things are same. Now, superposition theorem, when it is applied, I have stated already it is for linear, passive, bilateral elements. It is not applicable to the network containing non-linear elements. Okay. Okay, sorry. I think the slides. Yeah. So superposition theorem is applicable to linear elements only, and theorem is not applicable to the network containing non-linear elements. But I told you, if the corresponding one is expressed in terms of the linear active elements, then of course it is not applicable. Sources I mentioned earlier with respect to somebody has raised earlier the question, is the theorems are applicable or the KCL, KVL applicable to non-linear elements. If you consider the non-linear sources, they can be converted into the Fourier series expansion and other things. Strictly for non-linear sources, unilateral elements such as semiconductor devices, diodes, all those things, naturally we cannot apply the Thevenin's theorem because they are not linear, they are not bilateral elements in that sense, right? But another important aspect which is very much essential to understand, which is not being explained in the early beginning superposition theorem principle, because it is given in one of the examinations in some of the state level or I don't remember, or engineering services, then only we tried the importance of that. That is, it is not applicable to power through the element. What is the meaning of that? Because we say only algebraic sum of the current or the voltages only. So power is proportional to square of the current or square of the voltage. That is known. So therefore, it is applicable because when you square it, algebraic sum becomes. So same algebraic difference of the current only will be known, but when you square them, it cannot be directly applicable. So I will take an example of that which is given in gate, applying how you have to calculate if you want to calculate the power through that particular one. A typical example is being available to me. I will show that today. So sorry for the power interruption already for 5 minutes. It's not power interruption, it is Wi-Fi connectivity in the house is some problem is there. Anyway, we could reconnect it. So I have been discussing about this particular point. All dependent sources remain as they are while replacing the other sources because they are dependent. That point now I want to make it certain. So this is not applicable for nonlinear elements and unilateral devices. It's not applicable. Okay. So superposition theorem is applicable to only linear elements. Yeah. So now in example 1, directly I want to go straight away. So I will take few examples with respect to superposition theorem with respect to only DC networks, DC and AC networks also. So I got some typical examples. I got about 5 examples that have been collected. This is before that I want to explain to you a simple example of how we can go ahead with this, right? So with the DC, these are some of the own examples I have made for the ease of illustration. So for the circuit shown below, it is not a gate example, it is only for illustration purpose. For the circuit shown below, the current flowing through AB will be in figure 1. In figure 1, that is figure 1. This is the figure. Now, the second question is if source V2 is reversed, what will be the current flowing through AB? So this I would like to emphasize what is the meaning of algebraic summary currents. So when V1 is acting alone in this case, so this is the total V1, V2 are the voltage sources with equal magnitude I have given 6 volts and 6 volts, and 1 and 1 ohm is internal resistance of V1 and V2 like that, because they are connected in series with the voltage source, we can imagine like that. And this 1 ohm is shunt the resistance across AB that is required to be obtained, okay, where the current is required to be obtained. So that is a question. So this is so when there are two sources, one source is acting alone, V1. So short on the other side, short replaced by its internal resistance is equivalent to, if you treat this as a voltage source, practical voltage source, this voltage source is replaced with this resistance only in series. No additional change is there. Or it is replaced with the short circuit if this is ideal. And then this resistance is added, as it is added. So whether it's the internal resistance of the source or the series connected resistance, that is treated as the across a branch, that is treated as the corresponding source. So that anyway you can see from the Thevenin's network also at a later stage the replacement of the voltage source with the series resistances. Now R equivalent is 1 and 1 in parallel, 1 is in series. So this resistance, total equivalent resistance will be 1.5, right, from the source. So 6 by 1.5 is 4 amps. So current flowing through AB will be, you have to apply current division rule because equal resistance are there. I thought it is too simple. I have not given any formula here. So this total current taken by when 6 volts is given as the source acting alone, and the V2 is shorted, the current delivered by the battery, I can say, of V1 is 4 amperes, and applying the current division rule, the current flowing through AB will be 2 amperes. So that's what we have written here. Okay. Now so IAB is equal from, the current is flowing from A to B. When V2 is acting alone, so now short V1, apply 6 volts and find out the current through. So it is like I will explain this maybe in some other class called, this is a reciprocal and symmetrical network. Anyway, that is out of the context here. So this is current flowing through is again, this 1 and 1 are in parallel in series with it, equal resistance is same, total current from this side delivered by the second battery V2 of 6 volts also is same. So current going through AB is also same in the sense AB through AB also is 2 amperes. This is a typical example, just to quote. So the total current flowing through is 4 amperes because current is flowing in the same direction from A to B. Now the point of interest is you have to observe due to the each source acting alone in each of the branches. That is important. Okay. So if V2 is reversed, then current flowing through AB due to V2 will be, if V2 is reversed, that is you get from minus here and plus here, right? Minus here plus here, that is implied. Then same currents will be flowing through because but direction is from B to A we will get. Therefore 2 minus 2 is equal to 0 amperes. This is what I want to explain about the algebraic sum in superposition theorem, right? So second example, this is the one which I mentioned in the earlier basic KCL and KVL. I want to explain this using the principle of the superposition theorem. So for the circuit shown below, find the voltage across AB. Although already gate is solved, somebody has asked this question as how 10 volts current source, how you can ignore why it is not delivering the current, or what happened to the current delivered by the 10 volt source. So that explanation I have given earlier, but I don't know whether you understood that or not, because that time also I mentioned categorically that 5 amps current source is only actually delivering to the 10 volt source. So in that sense, now I will explain this typically. So this is 10 volt source, 5 amps is a independent current source, and this is 2 ohms. What is the voltage across AB? So this is independent current source, but there will be potential difference across the terminals AB. So when voltage source is acting alone, it is replaced by this internal impedance. What is internal resistance? Impedance or resistance is infinity because it acts as open circuit, right? Because it is ideal current source. It is not practical current source. So therefore, it is open. Therefore, although there is open circuit here, I have mentioned in the earlier class that open circuit voltage will be present across the pair of terminals because there is a connectivity here, right? So you can see there is a voltage rise from B to A, so that is 10 volts. A is a higher potential with respect to B. So when current source is acting alone, this one somebody asked also, I can answer to that question typically. What is the difference between voltage, potential difference and EMF? EMF is a generated voltage. The potential difference between B to A is the voltage. Okay, voltage across AB is called potential difference between AB. So potential difference is most often being used. The definition of potential you will study in field theory, that is different. But that is origination. A potential is the one which is being obtained from infinite point to the constant point. So the difference between the two points is the potential difference, where the potential is the electric potential is with respect to the two difference in potentials is potential difference that is measured in volts. That is why it is voltage. So that is the full definition, clarity between the voltage, potential difference and the EMF. Somebody has asked that question in today's or yesterday's question. So that all just keeping that in mind. I may not repeat that. Okay, if necessary, we'll say that. So anyway, such doubts can be easily clarified based on these things, right? So that is the difference between the potential difference, voltage, and EMF. EMF is a generated voltage, right? Even source voltage are generated voltages. So the potential difference between AB is the terminal voltage, load voltage, source voltage, like that you can talk about. Anyway, so they are being used synonymously. So when current source is acting alone, voltage source is being shorted, the current source is being placed here. So only 5 amperes of current directly flows through this. The potential difference between A to B is in the same direction. The current source is marked as plus and minus here. So current from B to A is 5 amps. Potential drop or voltage drop, potential difference actually, is also called as potential drop across AB is equal to 10 volts because A is at higher potential with respect to B, even in this case also. So therefore, the equivalent diagram, when both the sources are acting simultaneously, the total voltage across AB will be no current is flowing through, but it is only open circuit voltage. That is, it is algebraic sum of the voltages, right? So this is voltage rise is 10 volt source, and there is, although there is a potential drop from A to B in this case, the voltage rise will be from B to A. A is at higher potential compared to B. This is what you have to understand because the traversal is from B to A for finding the A. VAB means by notation also with respect to B, what is the potential of A? That is the voltage across AB. That is a standard notation. Okay, because it is a voltage across AB means voltage is not defined with respect to individual points. That is called only potential. So the potential difference between the 2 points only is the voltage drop or terminal voltage, load voltage, source voltage, etc. So with a double subscript notation here, VAB implies there is a possibility of voltage rise from B to A is taken as sign is A is considered to be at higher potential. Otherwise, we will say VAB is negative. Okay. So this is typical. So our explanation will be based on your general questions that are being asked also. Yeah. I hope you have followed that particular one. Next, the third one is another example which I have taken is a critical example which we have got an experiment in this in our lab in our campus college in the university, which I used to handle that earlier. So based on my experience, although lab equipment and other things are different, for calculation I have taken a typical example here. Carefully follow this particular one. This is too critical. That means earlier I have given one example with only DC sources. With yeah. Okay. Yeah, one with DC source. The second one with voltage and current sources together, applying the principle of superposition. Now this is another case where most of the times you need to understand the difference between the DC circuit and AC circuit. So this is quite critical, interesting, simple if you understand the philosophy behind it. And superposition theorem for DC circuits, only AC circuits, again similar, algebraic sum. But here it is equivalent to combination of the DC and AC. Okay, so let me explain this. So this is devised by me. Any doubts you can always ask after that also. Not from, it is equivalent to understanding from gate point of view also. Such questions are critical. For the following circuit, find the resultant current I. There is a 6-volt source that is being devised, given 3 ohms, 4 ohms reactance, inductive reactance, and there is a 10-volt source with polarity the higher potential at this point, and 10 at an angle 0. It is a AC voltage. It's 0 reference phasor. Now the first bit is find the resultant current I. Now second one is, this is devised by me. Further, if a moving coil ammeter is placed in the circuit at point A, what will be the reading of the ammeter? Okay, that is implied. What will be the reading? Means reading of the ammeter. If a moving coil ammeter is placed near this point or anywhere, it is only a series circuit, anywhere in the circuit. If the moving iron ammeter is placed in the at the point A, means in the circuit, that is in the circuit at point A, that is implied. Sorry, I have missed writing circuit here, but continuity is there. What will be its rating? So these are the 2 later questions which I got in my mind. So now you understand this point. So first one is, I will repeat the statement of the problem. For the following circuit, find the resultant current I. So the circuit given is 6 volts DC, 3 ohms resistance, inductive reactance of 4 ohms is being given, and this is 10 at an angle 0, and this is the voltage source. And subsequent questions I will explain based on the current that is being obtained in the circuit. Further, if moving coil ammeter is being placed in the circuit at A, what will be its reading? If the moving iron ammeter is placed in the circuit at point A, what will be its reading? So this is I found it is a very interesting question which I observed in practice in our lab. Not with the same values, but with a different distance. We used to test this as a superposition experiment, which is called as a complex wave. I used to mention RMS value of a complex wave. So that is why I used to give that title, and then I used to give it to the students for day-to-day classwork, which I do not know whether they have been doing in the affiliate college or not. That is a different issue. So when 6-volt source is acting alone, replacing the voltage source by this one, how the inductance is eliminated? Because it is DC, under steady state condition, that is implied. Under steady state condition, inductance acts as a short circuit. So therefore, voltage source is being shorted. As well, the inductance gets shorted. Equivalent, that is replaced with short circuit under steady state condition. The current flowing through this is 2 amperes. I1 is, due to the first source, DC voltage source is I1 equal to 2 amperes. I have designated that as IDC. I have DC current. When, this is 10 volts. Here I have written wrongly as 5, it is 10. So 10 at an angle 0, source is acting alone. So you can see in circuit also I have given correctly while writing small mistake is there. So 10 at an angle 0, 3 plus J4 is the corresponding impedance. So that is, the inductance offers the ohmic value due to the omega L. Omega is 2 pi F, that is implied. Need not be given. F is equal to 50 cycles per second. The value of the inductance is not required here because directly it is given ohmic value for the purpose of calculation. Okay. So 3 ohms and 4 ohms are being given. So the value of this is 10 by 3 plus J4. And from, again, in this direction, I2 is in this direction. So now 10 at an angle 0 divided by 3 plus J4 is 10 at an angle 0 by this magnitude is 10 at an angle 5, this is 5 at an angle 53.13 in the denominator, and finally this is 10 by 5 is 2 at an angle minus 53.13. So while writing some small errors I am making, but anyway, I know the answers, but while writing in my mind and writing there is slight difference. Okay. So 5 at an angle 53.13 is positive here. There is one correction to be made. This is 10 at angle 0, that correction is to be made. So this is 2 at an angle minus 53.13. Now, the resultant current is, so what is typical here is that this is current flowing through the DC circuit is 2 amps. Current flowing through this is also 2 amps. You will be tempted to say that current is flowing in the opposite direction. Therefore, its value is 0. But nevertheless, they are of the names and not same. type of the sources. One is DC source, the other one is sinusoidal fundamental component of the current will be flowing through the circuit. So therefore, it is I0 square. Resultant current is I0 square plus I2 square. Right? So this is rather typical. So the algebraic sum of the currents. So you cannot add the real component of this and the imaginary component of this. Is sinusoidal. This is DC component. So this is the total RMS value of the resultant current. If you want, we have to verify it practically also. That is a circuit behavior. That is a component behavior. So let us, if you want, you can verify that. So I is equal to square root of I0 square plus I1 square plus I2 square, but I1 is a DC component here. It is not the fundamental component notation. I1 is equal to 2 amps means ID is square, I mean to say here. For this particular one, the notation is slightly different. I2 is the RMS value of the current. So square root of 2 square plus 2 square is 2 root 2. That is 2.828 amperes. Okay, you will not find in any textbooks. This I have got my own idea on this to explain the difference between the two types of sources, including the principle of superposition. Otherwise, we'll be tempted to say that the current flowing through the circuit is zero because same 2 amps magnitude is flowing through from delivered by voltage source and delivered by the AC source. So this is another typical example, right? Now, the answer is first bit I have solved. The second one is moving coil meter. I give a 5-second pause. What is moving coil ammeter? It reads what? I am not explaining measurements here, but a moving coil ammeter gives the average value and it is applicable for DC sources only. So therefore, the average value of this circuit, this one is, even though you have got 2.828 amperes to measure, it doesn't measure. It measures only 2 amps. So you may think that it is meter fault. Okay. So therefore, because it is this idea I have got, because once I put the moving coil ammeter by the students, I observed that and in the AC source it is not reading. What is this? Why ammeter is not reading and machine is functioning? All those things. Because by mistake here, the students batch have put moving coil ammeter. So the ammeter reads only the average values. Moving coil ammeter reads only average value. Here average value happen to be equal, DC component is equal to 2 amps, so it should read only 2 amperes. If there is no DC component here, if you put instead of moving iron ammeter, you put the moving coil ammeter, meter will not read 0. You may say that the meter is not functioning and other things. So it, because we know for the average value, average power that is consumed in the pure inductive circuit or in the AC sinusoidal wave is 0. Right? So anyway, so in the sine wave form, it is 0. So it measures only DC wave, DC average values only. Average value for a sinusoidal wave will be 0. Now, if you put the moving iron ammeter, it measures the RMS value. It should read 2.828 amperes. So this is a typical one, and you need to understand this. This is what I understood from my experience. This you will not find in any textbooks. Now the next question. This slightly appears to be tough, but you have to understand carefully. It's a very critical, but it's not that difficult. But this is based on the power. Superposition theorem is not applicable to power, but if you want to calculate through the powers that are being given, how to calculate? This is a typical example. Now, given in GATE 1989, 2 marks. So luckily I got this particular question for illustration for you. So in the circuit of the figure, this is the figure. The power dissipated in R is 1 watt. Understand the question carefully. R is 1 watt. When source 1 is present and 2 is replaced by a short. That is voltage source 2 is replaced by a short. The power dissipated in the same resistor. Word is repeated unfortunately. The power dissipated in the same resistor is 4 watts when only source 2 is present and 1 is replaced by a short. So that is the principle of superposition theorem being applied. When both sources 1 and 2 are present, power dissipated in R will be. What is the answer to this? So there is a voltage source here. Typically the notation is C. Although we used to say if both polarities are given minus and plus, we used to say that it is a DC source. But here it is given as V1 e power j omega t. It is equivalent to, it is a complex wave. E power j omega t is cos omega t plus j sin omega t. So it is a combination of the sine and the cosine. Right? Anyway, this is also V2 e power d omega t. It is equivalent to treating it as fundamental sinusoidal only as far as possible, because cosine is only leading by 90 degrees with respect to the sine. So therefore, we can ignore that particular one for a while about the clarity of the voltage source and its implications. It is only a representation that is being made. It has got no values are being given, no values are being required to solve this particular problem. So ignore. Ignore in the sense, sometimes the unnecessary data also will be given to make us to understand which is relevant and which is not relevant also to be carefully understood. It is relevant in the circuit, but the data is not necessary for solving the problem of the current flowing through due to the both sources are acting independently, because the power that is being delivered by the source are being directly given. When first source is acting, the power flowing through this one is given as P1 is 1 watt. Due to the second source acting independently, the power delivered by this source is given as 2 watts. Okay? Yeah. So, there is a mistake. Okay. Now, in the circuit of figure 1, the power dissipated in R is 1 watt and one source 1 is present and 2 is replaced by a short. The power dissipated in the same resistor is 4 watts, then only source 2 is present and 1 is replaced by short. And both sources 1 and 2 are present, power dissipated in R will be. So, when source 1 is being present, the current will be flowing from this end to this end. And the second source is acting alone. This is the current flowing through from this end to this end. Now, you know the total powers. It is not the algebraic sum of the powers. It is only the algebraic sum of the currents. So, therefore, given P1 is equal to 1 watt, P2 is 4 watts. Okay, it is W, not M. While writing, small errors are there. So, since power is proportional to square of the current, I1 is equal to square root of P1, I2 is equal to square root of P2. This looks like M, but not W. Okay. So that is I1 and I2 are due to sources V1 and V2 respectively. The resultant current using superposition theorem through R will be from B to A is due to V1 and from A to B is through B is from B to A and due to V1 is from A to B. So the resultant current is I. So this is minus I1 plus I2, not both negative. Sorry, small errors are there while concentration is required. I know the answers, but writing I am making errors because okay. The resultant current using, because we are not finding time after the explanation, again working for 2-3 hours, understanding the problem, writing that, making this in the PowerPoint mode, taking the help from others, sending the WhatsApp and other things, we are losing concentration anyway. But anyway, I am trying to make an effort. So the resultant current is superposition theorem from A to B is taking this direction, minus I1 plus I2, A to B if you want to get. So anyway, it is algebraic difference. So therefore, assuming current flowing through AB, that is what I have written here ultimately. Assuming current flowing through AB is positive, then current flowing through BA will be in opposite direction. So this is I2 minus I1 whole square into R. So ultimately what I want to say is, due to the V1, it is from, if this is B, this is A, general convention, A here, B here, or B here, A, same. So current flowing through due to V1 would be from B to A. Current flowing through from V2 would be from A to B. So I2 is from A to B. I1 is from B to A. That's what I would like to state. Ignore if you are not followed here. Okay. So there is no need for any further questions on this because I have already clarified this point. So I2 minus I1 whole square into R. So now, because the current is proportional to square of the power naturally, or P is proportional to actually square of the current, proportional. So I1 is proportional to, this is proportional. I1 is proportional. I made equal to also doesn't matter. Okay. So I2 minus I1 square into R. If it is 1, its value is same. But anyway, it is proportional. So I have multiplied it, let us say multiplied by R. So square root of P2 is 4, square root of P1 is 1. So 2 minus 1 is 1 watt. So it's very typical. Whereas you may be tempted to say that, and so the answer is 1 ampere. You may be tempted to say 1 plus 4 is 5 watts because 1 is due to 1 is 1 watt, the other one is 5 watts. It is not correct. and maybe the other things are also directly being added. Okay, so how do you get these things is out of the context, but so this is typical. So I repeat the statement of the problem. In the circuit shown in figure 1, power dissipated in R is 1 watt and source 1 is present and source 2 is replaced by a short circuit. The power dissipated in the same resistor is 4 watts, that is this point, this is R. When only source 2 is present and 1 is replaced by a short, and both sources 1 and 2 are present, power dissipated in R will be. So here, applying the principle of superposition theorem directly not applicable to the power sources. You have to take the only current sources, algebraic over the currents. They are of the same type. They are of the same type. And it is only purely resist to 1. Okay, so therefore no problem. Even though there can be phasors, they are the phasors, they are of the same type, no problem at all. So that is why we got algebraic difference in the same resistor circuit, I2 minus I1. I2 is due to the second source from A to B, that by convention. So this is from B1, this is I1. So from B to A, because this is given in the opposite direction. Okay, this is not a DC source. The polarities are being given like that. That is the only thing. Generally, we don't provide in our normal conventions. It is gate question paper that is being mentioned. I don't have anything to say. So this V1 E power J omega T, V2 J E power J omega T, the data is not necessary. So it is only to make you or the student or the examinee to get confused. That is the only thing. Because you have to see the pattern, you have to understand which data is relevant, what need to calculate, all those things. So that is a lot of attention is required in solving these problems and solutions for this. So the algebraic sum of the currents flowing through the due to each source acting independently, we have to consider. So when we have considered V1, it is from VTI is obtained as 1 watt. So that is proportional to square of the current. So there is nothing wrong in assuming here. It is only assumption. I1 is equal to square root of P1 later multiplied by R. That is proportional to square root of P1. So this is assumption. Anyway, that is which one known. Later I multiplied with R. So no problem. So similarly, I2 is equal to square root of P2. So therefore, it is I2 minus I1. There is error here. Minus I1 plus I2. That is I2 minus I1. Because again, I do not know which one is higher at the time of calculation. So from B to A or A to B, I assume to be positive direction. If you get B to A more, then the actual direction will be from B to A. So because of the algebraic sum. So that always is possible. That is called principle of hypothesis. We assume in one direction. If the direction is reversed, the actual current has to be considered based on the calculations. So then you confirm that you ascertain that the actual direction of the current is from either from A to B or from B to A. So one you have to start with some assumption. That is called principle of hypothesis, right? So anyway, the resultant power is before that, assuming current flowing through AB is positive and current flowing through BA will be in opposite direction, so negative. So it is I2 minus I1 is the total algebraic sum of the currents. So I cannot write P2 minus P1 whole square. That is the only essence to say in this particular one. Right? It is only I2 minus I1 whole square into R. R being same. That is 1. So P2 is 4. So square root of P2 is 2. P1 is 1. So square root of that is 1. So 2 minus 1 whole square is 1. So it is only 1 watt. So it is rather typical. How it happens is that is a circuit behavior. That is how you have to understand carefully. When one of the sources is delivering 1 watt and the other one is delivering 4 watts, still based on the directions of these things that have been given, it is because this is opposite direction, it is algebraic sum. So therefore, I2 minus I1. If it is also same direction as from A to B, if it is given reverse polarity again here, it will be from A to B. So that will be 1 plus 4 or I2 plus I1. So then it will be root 5. So based on that, you have to get. So one need to be careful about this. These are all, that is why they are all tricky issues. It is not just easy to explain also on this thing, because you need to be attentive, you need to follow this, and there should not be any errors, and all these things. These are all tricky. You know, this is given for 2 months, means those days be able to solve within 1 to 2 minutes time. So it's a 3 hours test, and those days I think it is for 200 marks that has been given. So you should be able to solve in 1 to 2 minutes, understanding the principles and other things. Okay. So anyway, this is typical. So this is only to explain superposition theorem. Yeah. This is another typical example. So based on the superposition theorem, this is I don't know when it is being given. Anyway, I got this example. Okay. So in the figure shown, the value of the current I in amperes is the value of the current in I. This is the fifth problem. Remember, only superposition theorem. I am giving the fifth example. So each one is typical to itself, right? So theorem statement is one thing, understanding the theorem, and now you are more matured, perhaps because you have studied, written the exam and other things. Here it is only again understanding things. So it is not going fast. Assuming that you have already done that, it is just going through the examples. And so in the figure shown, the value of the current I in amperes is this is 5 volts DC source, this is 5 ohms, this is 5 ohms, and this is 10 ohms, this is 1 ampere. Okay. So the current I to be obtained is from the 10 ohms resistance, through the 10 ohms resistance. That is the question. So what will be its value? So one is a independent voltage source, the other one is independent current source. So when 5 volt source is acting alone, I replace this by a open circuit. 5, 5 and 10 are being given. So in series. So due to the first source acting alone, I1 is equal to 10 ohms. Right? So I1 is total is 5 plus 5 plus 10 is 20 ohms series resistance. So 5 divided by 20 is 0.25 amps. When 1 ampere current source is acting alone, okay, when 1 ampere current source is acting alone, this is replaced with voltage source replaced by a short circuit or by its internal resistance of 5 ohms only. That's what again. This is 1 ampere and this is 5 ohms, this is 10 ohms. So now you can imagine that this current source is having two parallel branches. One is 5 ohms resistance, the other one is series combination of 5 and 10. What we require to find is current through 10 ohms resistance due to the current in the current source. So now we apply the current division rule. The current through the 10 ohms resistance due to the second source of 1 ampere is flowing is considered is I2 is equal to total current multiplied by opposite parallel resistance. So opposite resistance, that is opposite branch resistance, opposite element resistance here. Again, do not get confused. Branch means in graph theoretic branch. That is a different context. Okay, so that is why every chapter is not is having its own notation. That is a typical thing, right? Anyway, so opposite branch resistance divided by sum of the two resistances. So sum of the two resistances, not two. Sum of the two parallel branch resistances. Parallel branches. There are two parallel branches, one with 5 ohms, and these two parallel branch has got equal resistance of 15 ohms. So I 1 ampere into 5 divided by 5 plus 15. That should not be ignored. Right? So that is 0.25. Now you can say, one may be tempted to say that the algebraic sum is difference. It's not the difference always. Algebraic sum means now due to 5 volt source, current is from this end to this end. Maybe A, B. This is A. Always we take this A, B by notation, although it's not given. We can easily assume that. You can easily look into that. So A and B is from A to B. Due to 1 ampere also, whatever may be things, still it is from A to B only. So it is 5 plus 5 is 10. For example, if any one of these sources are reversed, then you will get 0. So that is the typical nature of this particular problem. You have to carefully understand. Algebraic sum of the current flowing through applying the principle of superposition due to each source acting independently. I hope I have given some clues of understanding superposition theorem instead of raising more questions on this. Anyway, questions are always welcome, but only thing is I will be able to answer only subsequent days. So today I have come prepared with questions of unit the yesterday's lesson. So 13th day lesson is yet to be done. Maybe some other day I will do it. So this is only superposition theorem. I have some more time. I will discuss one more theorem now. Okay. So that is why I used to say that it is concept and material also is very important. And instead of covering the entire syllabus of 1 year course that has been taught in 2 semesters, in 2 semesters or 1 year courses earlier, it's not possible to cover the entire thing in 12 sessions only, but with including interaction with a small period of 2 hours. So maybe a 2 hour session in the morning, 2 hours in the afternoon of the same subject is too tedious. 2 hours itself is too long a period for interaction in a classroom environment. Of course, we are habituated to give 2 hours lectures because our subjects demand like that, not only circuits, power system analysis, and even synchronous machines. These are some of the field theory. You cannot just stop in between for the derivations or the concepts. Every day you cannot have a separate beginning. So continuity should be there. So for that, we always tend to take not less than 2 hours for the sessions. Minimum is 2 hours. And that we are limiting to that always, most of the times. Anyway, so this is only just a stopgap for a few seconds for the next theorem to be stated. So maybe after the explanation of the Thevenin's theorem, if time permits, I will go to one more theorem, Norton's theorem. Although I come prepared for 4 theorems in today's this one, I want to spend about 30 minutes to 45 minutes for the question and answers of the yesterday's session. If still time permits, then I will come back to the other theorems, right? So that is how the lecture plan will be there, because I understood which one should be done first. Okay, the previous this one to be answered first or today's lesson. I found explaining today's lesson, if I start answering the questions that are being raised by others, in between if you have got any doubts, you can start typing the for the today's lessons also, so that I can explain on some other day. Okay, so anyway, it is a continuous process. So because online charting is not there, but it is difficult also because thousands of students are appearing in all the subjects put together. So there should not be any overlap or gambling. Anyway, it's a good beginning we have done in this particular context. So I will start. There is only just a stopgap discussion for the next theorem to go through by me for understanding for you. So Thevenin's theorem is the most important theorem, and I would like to, if time permits, Thevenin's and Norton's theorems together I would like to discuss. In the sense, both at once. So even if it takes us up to 4:30, it doesn't matter. So that the remaining half an hour I will spend for the other thing. Even maximum power transfer theorem also is linked with Thevenin's theorem and Norton's theorems. That you know that because maximum power transfer theorem is linked with jet Thevenin. Anyway, so in any two, the statement of the theorem is already known to you, but I will explain once again. In any two-terminal electric network consisting of one or more independent or dependent voltage or current sources can be replaced by a single voltage source VOC in series with, sorry, there is small confusion here in the words, in series SCRIES with equivalent impedance Z equivalent. So this is a network representation, a block box representation. AB are the terminals and ZL is the load and V0 or VL is the load. I is the current or IL. So this is to be replaced with VOC, Z equivalent. So in any two-terminal electric network consisting of one or more independent or dependent voltage or current sources can be replaced by single voltage source in series with equivalent impedance. And how these things are being obtained, when it is applicable, what is the equivalent of this one, you may be familiar, but anyway, this is very fundamental theorem. So all independent sources are replaced by their internal impedances as already stated, which is common for all the theorems, wherever the replacement of the independent source are to be done. This question is very important. All dependent sources remain as they are. They cannot be replaced. Yesterday somebody has pointed out that. So that indirectly is being answered in today's discussion also. In various cases when you cannot replace the source transformation is not possible with respect to the dependent sources. That is a question that is being asked. So this theorem is not applicable to the network containing non-linear element and unilateral elements. Okay, VOC is obtaining by removing the load across the terminals and finding the voltage across that. That is, you know the principle. and depth Thevenin is obtained by removing the load and finding the equivalent impedance by looking back into the terminals of the network. So then IL will be equal to VOC by depth Thevenin plus ZL. These are the fundamental aspects. So I repeat the statement of the problem. In any two-terminal electric network consisting of one or more independent or dependent voltage or current sources can be replaced. Again, I would like to state that here linear, passive, bilateral, active network elements, all these also can be added. So in any two-terminal electric network, generally they contain all these things, all the four: linear, passive, bilateral, and active elements. Then we have got elements in the classification dependent or independent also I have added. Current or voltage source also we have added. So that can be replaced across the pair of elements, pair of load terminals. Now, what is the advantage and why we should study this? After all, when we are able to solve the problems, now the several questions will arise. Suppose you have got one network is to be replaced between this. Not only you can find the load current. After all, for finding load current, why we should do this? Suppose I have got a change in the impedance. Do we have to, suppose ZL is changed to some delta ZL plus delta ZL. So do we have to calculate for the entire network again, resolve the problem, or with the known value can you do it? So those things can be done with substitution theorem, compensation theorem, all those things. So that is the advantage of these theorems. So the work that is being calculated up to the previous point where there is no the first element that is being kept. Suppose the impedance or resistance in the circuit at the load point AB is increased or decreased. What is to be done? You say that you recalculate again. Okay, that is everybody's guess. But the theorem has got some advantages if you do it like this. Not only that, why we should use Thevenin's theorem? In the source representation, Thevenin's theorem is the base. Already we have done even in the first this one, KCL, KVL, source transformation we used to say, but source transformation is based on this. But where do we start? First we start with theorems to explain before explaining the basic concept of the sources and representations. So all these things are critical. So these are all linked topics. So one after the other. So sometimes the questions can be answered only at the end also. But only if we have a question on session only in a particular lecture, I don't know how many people will attend. Anyway, so it is not the question of these things, but these are interlinked topics, right? So all independent sources are replaced by their internal impedances. All dependent sources remain as they are. So this term is not applicable to the network containing non-linear elements and unilateral elements. Unilateral elements are those semiconductor devices. Current flows through only in one direction and it is forward biased. Right? Okay. So VOC is obtained by removing the load across the terminal, not just removing, temporarily. Again we will put it back and then that is why you get that. So this is the equivalent and Z equivalent is Z Thevenin. Right? So this theorem is not applicable to the network containing non-linear element and unilateral elements. VOC is obtained by removing the load across terminals and finding the voltage across the terminals AB. So Z Thevenin is obtained by removing the load and finding the equivalent impedance by looking back into the terminals of the network. So this is some of the examples which I would like to solve. So I have taken a critical example which is given in GATE examination because I tried to solve a good number of examples with each of these things. So I found more in Norton's and Thevenin's theorem in GATE examinations, but they are all typical. Okay, even for Norton's theorem you need a Thevenin's equivalent impedance. Even for maximum power transfer theorem you need a Thevenin's equivalent impedance. Anyway, you see the tough problem. I have selected a tough problem here in that sense. The Thevenin's equivalent voltage, V Thevenin, because while solving good number of exams, there is no limit for that. Which one is to be selected? How much time I have got? All those things matters. Otherwise, it is a continuous process. I don't mind if time is given for this at a later stage also. It's not that today, this 12 days is the end of the entire course. If the university wishes to continue at a later stage before your GATE examination, which is to be scheduled subsequently in 2021 GATE, maybe you may come back with clarifications of the doubts, if time permits. and if everything goes well. It's not that how much content is being presented, whether given complete entire syllabus of 1 year in 12 lectures or the other things. So, but I want to give you the clarifications more time than the actual content to be delivered, because it is a circuit problem. It's a theory means 1 hour theory and remaining question and answers is okay, but every theorem might take half an hour sometimes. I used to teach for 1.5 hours in the lecture classes in daily these things, particularly Thevenin's theorem, superposition theorem, Norton's theorem, have got their own implications in these things, right? Anyway, now take the example. Thevenin's equivalent voltage V Thevenin is appearing between the terminals A and B of the network keys. Now these are the terminals A, B. So it is given the solution. J16 into 3 minus J4, J16 3 plus J4, 16 into 3 plus J4, 16 into 3 minus J4, etc. These are the 4, 1999 2 marks question. So the circuit is redrawn as only to identify the terminals AB. So this is I is being shown. So voltage across appearing across the terminals A and B means it is open circuit voltage across AB. No load is there further, but the voltage appearing across the inductance itself, the current flowing through multiplied by the impedance, the reactance of that should be the open circuit voltage here. That is why it is shown to be redrawn. That is a change in this circuit to this. Why I have to consider that? Because I understood that VAB is same as the voltage appearing across the J4. That is reactance. So in order to get that, I need to get the current. Now let us try to get the current. So VAB is obtained as I into J4. Now what is I? Right? So this is 100 at angle 0. Right? Now you can see it is seem to be complex, but it is too simple here in the sense. Why I have taken I is equal to V by 3 plus J4? Why not I have found the equivalent impedance? Because these two are parallel branches. The voltage across this is same, irrespective of the element values. The potential difference is the source voltage here. So although the potential difference is across AB is only through J4, the voltage across the J2 ohms reactance and the minus J6 ohms capacitive reactance or capacitance is same as the supply voltage because they are parallel. So that should not be get confused. That is the only point, right? So therefore, the current flowing through this one is V by 3 plus J4, 100 at angle 0 by 3 plus J4. So it is no doubt, it is extra data, unnecessary data for this particular problem. If the circuit is like that, that is a different issue. What is asked, what data is being given, whether it is data, everything you have to require to solve, certain things can be ignored. When to ignore, when not to ignore, when to consider, judiciously we have to do. It's very critical that way. So that is why each theorem takes its own time for its understanding and delivering things. But anyway, Thevenin's theorem can be explained for other theorems also. So I have collected only one good example for this, right? So 100 at angle 0, and so divided by 3 plus J4. These two are parallel branches. So only current flowing through this particular branch. Although current flows through these things, what is our screens? Only voltage occurring across AB. That is the equivalent to Thevenin's equivalent voltage only because it is open circuit voltage. So that is the typical, right? So that means, okay. So imagine that there is no further load here. This voltage is going to be taken as this one only. Not that AB is taken as the load condition and that is being put and then find the current and other things. No. Here AB are the terminals where there is no further load is being considered. Okay. So the voltage across AB is same as the voltage across the J4. Even that can be, even if you take this as AB, remove the load and find that one, the calculation can be different. And that you can try to do that. I am giving another solution to that. You try to do that because this is one way it is being worked out in this particular fashion. If you find that you find the terminals are AB like this, remove the load condition because it is also connected across it and find the open circuit voltage between AB. Is it possible? Okay. So you try and then tell me whether it's correct or not. Okay. So I mean, it is which is correct. We have to judiciously understand. So for the terminals which is being given AB, which is external to the value, this value is already in the circuit and it is expected that some more load would have been connected because the terminals AB of the network is, we have to find the open circuit voltage. That is, it is already considered the load data is not being given. Okay. If by mistake, if you take this as the, if by mistake this is taken as the actual element and that you have to open again, then it may mislead. Okay, this will become open circuit voltage. So no current can flow through this particular one up to the whatever the corresponding source voltage will be there, because suppose you take this as the open to be open, then no current flows through this element because there is open. So same voltage, this voltage is supplying to the parallel impedances, that is reactance here, capacitance here. So no current can flow through if this is not being considered, or this is being considered as one of the directly the load terminals. So the load terminals are only AB, implying that AB, across AB no further load is there, and that is being temporarily being removed for the purpose of identifying the circuit to get the open circuit voltage. Otherwise the solution will be different. So that is where one can go wrong. So it requires a lot of explanation. Okay. So what I mean to say here is VAB is equal to VOC because of the reason that it is being open circuited already. No additional load ZL is being shown as the additional data. That is first point. If you treat this as the AB terminal and you want to remove the load and find, this will become the open circuit voltage across this. AB will be, no current can flow through in the circuit because this is parallel, this is voltage, and this you are going to remove for finding the open circuit voltage, removing the load. So therefore there is no current can flow through, and the open circuit voltage will be same as the 100 at an angle voltage 0 direct. No, this one. So you will not be getting the choice, assuming that one of the choice is correct. It's also equally important. Assuming that one of the choices is correct. So just because it is not tallying, I may change, or maybe that is wrong. You can say that it is not tallying. Somebody even points out there are even few cases when multiple choice answers are not being correct. So you have to be careful about that. And some people have given consideration to that and giving the that may be deleted in the pattern, and so many other issues are there. In the sense, maybe that 2 marks is deleted for all and counted for the remaining. Not only in because if really there is something wrong, then definitely people will consider it. But this is typical. So our thinking is wrong in this. So not only the right answer which is tallying I am justifying in this case. If you go wrong in this, treating this as the parallel value of the element that is being connected, then you will go wrong. Anyway, that is not the case here. So that is why the explanation to this takes more time, because these are all critical subjects. One of the very fundamental hardcore subjects requires a lot of understanding, explanation, depth of knowledge, and accuracy, diligence, and the presence of mind also. And the clarity is required, and also concentration. These are the things that are required for understanding these particular topics, right? So it's not that easy. That is why this is one of the, it's not tough, it is a fundamental subject. We can't get away with these subjects. We have to study these things, we have to understand. That is why electrical circuits or electrical engineering subjects are relatively much tougher, involves in higher engineering mathematics and higher imaginations, right? Right. So anyway, so now coming back to this particular problem. So you can see one question is taking more than 15 minutes time to explain this, doesn't matter. So the circuit is drawn as this one, showing that AB here. So I is current is shown here, okay, I. So VAB equal to I into J4, that is because VAB is equal to this voltage itself. So V by 3 plus J4, because this the voltage across this, the voltage across this are same, right? So I into J4. So I is equal to V by 3 plus J4 is 100 by 3 plus J4. Now, so VAB equal to I into J4. So 100 at an angle 0 into J4 divided by 3 plus J4. It is always, when you have got the denominator in this, you have to multiply by a complex conjugate pair to make it real in the denominator, so that you can separate the real and imaginary parts of the complex voltages or currents or impedances, etc. So it is a standard pattern. Even some of you have asked in the earlier under previous questions in steady state analysis, how this RL by RL plus XL JXL is being converted into two separate parts. So similar to that, it is a standardization. In some of the textbooks, I found this as reciprocation. No, I don't want to call that as reciprocation because maybe mathematics people may want to use the terminology. I found taking reciprocation. I'm not convinced with that. I only say that multiply by the complex conjugate pair of the denominator, both numerator and denominator simultaneously. So that the value of the numerator by denominator values doesn't change when you multiply by the same quantity. So you have to multiply by the complex conjugate pair of the denominator to make this to be separated into real and imaginary parts. So this is 100 into 4j divided by 3 plus j4 is here after this step. So multiplied by the complex conjugate pair, this will become 3 square plus 4 square is 25. So 104 by 25 into j is there, 3 minus j4. So this is 16j into 3 minus j4. So still it is not, it is given like this, so we have kept it that early. If you want to really separate the real and imaginary parts, you multiply further. 48j and this is 16 into minus j. 16j into minus j is plus 16j into 4, 64. So this would have been written as 64 plus j 48. So that means it is of inductive type, which is not being given, so I am not telling that. So if you take further step in this, actually 16j into 3 minus j4, what is the final solution? What is the nature of the current voltage? What is the nature of the current? So 16j into 3 is 48j. This is the reactive component. And 16j into minus j is plus 1. J into minus j is plus 1. Okay, that you know. Minus j square is minus 1 into minus 1 is plus 1. So 16j into minus j4 is 64. That means it is 64 plus j48. 64 is the real part. 48 is the reactive part. This is the actual current. So that means when you have taken 100 at angle 0, so 64 plus j48 is inductive. Although VAB is voltage across that, it is based on the current flowing through the inductor. So this is the explanation. I think I will try to explain one more theorem because the properties are similar, except for Thevenin's equivalent impedance is same and Norton's current is only slightly different. And yeah, so in the next 15 minutes, hopefully, I will try to cover the Norton's theorem. Then I will go for question and answer sessions from 4:30, so that if time permits, I will come back to the next one, that is maximum bottom theorem. Otherwise, that will be starting tomorrow. I would like to discuss some more theorems in next class, no doubt about that. Because although I said 4 theorems are only being mentioned in the GATE examination, it's not that only 4 theorems are sufficient for even understanding subsequent subjects in power systems and other things. So we need all the theorems. Anyway, so I mentioned that in my introductory talk. If you are not present sharply at the time of beginning, and again, this may be useful sentences. So Norton's theorem. In any electrical network consisting of linear, bilateral, passive, and active element, the network prior to the output terminals can be replaced by single current source in shunt with Z equivalent. Similar. So I have, if you want to give a complete sentence like Thevenin's theorem, also you can do, except for the voltage source, you say current source, and instead of series with Z Thevenin, you make it as shunt with Z Thevenin. So although some people ask, when you are talking Norton's theorem, why this resistance is Thevenin? Perhaps simultaneously they might have done, and one has discussed about voltage source, one has, because they are names, others' names, scientists. So one has found out Thevenin's and Norton's simultaneously, and Thevenin's equivalent impedance, the internal impedance of the network is being identified maybe first by Thevenin, so that is being carried here. Same thing here. Only thing is, he talks about, Norton talks about short circuit current here, whereas he talks about open circuit voltage. So they are dual properties anyway. So other than that, there is no difference in this particular, but that itself is a difference. Okay. So any electrical network consisting of linear, bilateral, passive, and active elements, the network prior to the output terminals can be replaced by a single current source, which is referred as ISC, short circuit current, or Norton's current IN, or IAB, current through the terminals AB, in shunt with Z equivalent. This Z equivalent is shown to be Z Thevenin. So this is the standard representation. This is the network of the in a black box that is being shown. AB are the terminals for the load, ZL is the load impedance, IL is the load current. AB are the terminals, V is the output voltage across the ZL. So the Thevenin's voltage is the Thevenin's current, the equivalent Norton's current is IN in parallel with this Z Thevenin. Z Thevenin is same as Z equivalent, so therefore we don't represent that. IN is obtained by short circuiting the load terminals, finding the current through it. So remove the load here. Earlier we have done open circuit voltage measurement. Now we have to short it. That is to find the Norton's current. Thevenin's and Norton theorems are GL. This is one observation I have made. Okay. And IL is load current can be obtained by current division, simple current division rule, but they are phasors. It's not numericals only. Okay. IL is equal to IN into Z Thevenin by Z Thevenin plus ZL. So whatever the statement that have been given, it is applicable to the linear elements only. For non-linear elements, it's not applicable. All those things, whatever that has been stated for Thevenin, equivalent one also is applicable to the Norton's theorem. Perhaps you might be aware. So I want to concentrate on some more problems on this. Okay. Yeah, I have got two problems for this. Maybe I have chosen tough problems in the sense they are quite complex because they are given in the multiple choice questions here. Yeah. So in the circuit shown in figure, the angular frequency omega at which is Norton's equivalent impedance, same as Thevenin's equivalent impedance. It is only to confuse you. There is nothing like Norton's impedance is same, not same as the Thevenin's equivalent impedance. Norton's impedance or Thevenin's equivalent are same. Norton's equivalent impedance as seen from terminals B to B dash is purely resistive. Okay, so that is typical. In the circuit shown in figure, the angular frequency omega in radians per second at which is Norton's equivalent impedance as seen from terminals B dash is purely resistive. So where is the question going on? Is there any zigzag that? No. Yeah. It is. Yeah. I think multiple choice question is not that. So you have to find the omega. Yeah. Sorry, it is not a multiple choice question, but it is a question given for 2 marks in GATE. Okay. So because it is lengthy, we have split that into 2 parts. So 2 slides are there. Okay. So now I repeat the statement of the problem. In the circuit shown in figure, the angular frequency omega in radians per second at which is the Norton's equivalent impedance as seen from the terminals B to B dash is purely resistive is. So 10 cos omega t, there is sinusoidal wave with people might say sinusoidal wave, how it is sin omega t and cos omega t are cos omega t is sin omega t plus 90. Okay, so therefore it is a positive leading edge at the time of starting at time t equal to 0. So peak at its peak value because cos 0 is 1. So at sin 0 is 0, this cos 0 is 1. So that is cosine function leads by sine by 90 degrees. So it is a leading phasor, or it is a vertical axis sine convention that is with respect to the reference phasor. The source is shown as vertical axis, vertical one, 90 degrees leading. So that is how one has to understand this. So there are typical way of giving the questions. Okay. So in the circuit shown in figure, the angular frequency omega and radians at which the Norton's equivalent impedance as seen from terminals B dash is purely resistive is. So 10 cos omega t, 1 ohm, 1 farad, 0.5 henries, and B dash. So to find Z Thevenin, let us find the Z Thevenin between the terminals B dash. So remove the voltage source by a short circuit here or equivalent by resistance here. So it is not the internal resistance of the source, it is a 1 ohm external resistance because it is a sinusoidal source which will have impedance only, synchronous impedance of alternator. So therefore, anyway, that is out of the context here. So it is only a voltage source up to this point, it is only a voltage source that is being shorted. Assume that is an ideal one, doesn't matter. So 1 ohm and this is 1 farad, this is 0.5 henries. So omega is to be obtained, so inductive reactance is omega L. So this is 0.5 omega. 1 and 0.5 omega are in parallel in series with 1 by omega as viewed from the terminals B to B dash, as viewed from this, that is important. You cannot view from this. If you view from this, these two are said to be in series. So that is rather typical. If you want to find the open circuit voltage, naturally, if this is already B to B dash is concerned, I would have said that this is no current can flow through this is in series, and you would have found that. But for finding the Thevenin's equivalent impedance, you have to view as though you are viewing the network from the terminals. That is why we state that is very important as looking back into the terminals of the network. That is very important statement. Looking back into the terminals of the network. That means as viewed from the terminals, you have to find out. That is called looking back into the terminals. There is no other choice. So replace the voltage source in this and then find out this. Why we have to do that is Thevenin has originated that particular statement maybe centuries of years ago, right? So anyway, these theorems are very critical, right? Very, very important. So as viewed from these terminals, right? So therefore, 1 in J.5 Z Thevenin to be obtained is 1 into J.5 divided by 1 plus J.5. This is the corresponding parallel equivalent impedance plus 1 over J omega. Okay? Because 1 over J omega C rather. Minus J 1 by omega C in that sense. Either way it is same. So I take this value, convert that into ZBB dash is equal to same as Z Thevenin. So taking this one, multiply by the complex conjugate pair, we get this, and so multiply by the complex conjugate pair, solve this one, separate the real and imaginary parts. In order, Z Thevenin must be resistive, imaginary part of ZBB dash must be 0. What is the meaning of being resistive? Z Thevenin must be resistive. Okay, so that is a purely resistive circuit. That means it is a typical one. If it is a series circuit, the Thevenin's equivalent must be a resonating one indirectly. That is not the essence of that. So the Thevenin's equivalent impedance must be purely resistive. Okay, so it is equivalent to, if you find the total, but you know the total circuit is not under resonance condition. You should not get confused with this, because as viewed from the terminals B and B dash, the circuit should be behaving purely resistive impedance. The imaginary component of the reactance, imaginary component of the impedance, that is reactive component, must be made equal to 0. So that is how, by multiplying this complex conjugate pair, you get this simplification. Omega cube minus 4 omega by omega power 4 plus 2 omega square. So that means numerator is equal to 0 and omega cube equal to 4 omega square equal to 4, omega equal to root 2. So this much of solution is to be obtained for simplifying these things. I have not explained the complete this one because you can do it, and already these things every day they are putting. So all the first 4 days lectures have been put in the university website. I could check that also. So therefore there should not be any problem. Any doubts, further clarifications? Because this is a workload problem. In the sense, why, as I told you, this is a wonderful textbook which I got during this pandemic period. Otherwise, I would not have been able to explain it at this level, because I need to calculate afresh. Solving this particular problem takes, each problem can take its own time. But anyway, I'm lucky to get a problem solved question papers. A2009 made easy publications. I repeat that because every day at least one new person, if they join, they will not be able to understand where from I have got this. Made easy publication, Gate 2009. 32 years solved problems are there. Some of them I have picked in this. Okay, already I have been telling every day. So, because for explanation, I have collected these things, trying to understand and giving the solutions. Okay, so yeah. So one more question here. In the circuit shown below, I hope I have not gone fast here. The simplification part only I have not done explained to you. Okay. Otherwise, as viewed from the terminals, only this is complex calculation. It takes some time to understand. Maybe you have to read once again and see the correctness of that. And so omega equal to root 2 is the solution, right? Now, next question. Because after this, I will contend with the only 3 theorems, that is superposition theorem, Thevenin's theorem, Norton's theorem. Then the remaining time I would like to answer the question and answers of the previous this one. I hope time will be sufficient, and up to 5. Maybe if extend 5 to 10 minutes, not more than that I would like to extend. So after this I will go to the question and answer sections. So a few seconds break will be there to change over the slides. That is the only thing, right? So in the circuit shown below, the Norton's equivalent current in amperes with respect to PQ is? With respect to PQ is. Okay. In the circuit shown below, the Norton's equivalent current in amperes with respect to PQ is. So 16 at angle 0 is the current source that is being mentioned. This is J25M, that is inductive reactance ohmic value. This is J30 ohms, inductive reactance ohmic value. Even 30 ohms, even if J notation need not be given, but luckily you are being given. So this is minus J50 ohms capacitive reactance, and this is 15 ohms resistance. And here the current source is being asked. So therefore, with respect to PQ, the Norton's equivalent current in ampere with respect to PQ, that means it is a short circuit current. No additional load is being considered. So it is equivalent to, even if the load is there, you have to short it. So therefore, the question of the voltage and this parallel element taken doesn't come into here. In the sense, you first short it. So the equivalent circuit now, it is a gate question. This one for multiple choices. I don't want to read this complex values because it is for 1 mark only that is being given. I've got only about 5 to 7 minutes time to go for the subsequent question and answer section. But I will not go fast. But this data is not necessary to read. There are 4 multiple choice questions because they are complex quantities. 6.4 minus J4.8, 6.56 minus J7.87, 10 plus J0, 10, 16 plus J0. So many things are being given. Okay. So the equivalent circuit to find IN through PQ is IN is shorted. Now you may ask me the typical fundamental question, because the way you are asking the questions, you will ask me, sir, earlier you have taken that voltage across that inductance load లేదు కదా, మీరు లోడ్ పెట్టకుండా మీరు ఇండక్టెన్స్ వోల్టేజ్ నే తీసుకున్నారు, ఎక్కడికి వచ్చేమో షార్ట్ చేసేసారు, కెపాసిటెన్స్ తీసుకోలేదు అని. Because it is even if you have got a load there, then you have to short circuit that one, because short circuit current flowing through the terminal PQ is the Norton's current. That is important. You have to understand the statement of the question, statement of the problem of the question that is being given carefully. So that is equivalent, very typical in that context. So every problem is not unique in solving it. The solution methodology is same, but solving the problem of each nature, you have to think independently, right? So it's only 1 mark question that is being given. So now you can short it. When you have shorted, the capacitance has no effect, right? So this J30 ohms only together with 15 ohms. Now when this is shorted, PQ is shorted, this capacitance is shorted, then 30 ohms and 15 ohms are connected in series, and this is being current source. The current division rule I have applied. So this much of idea has to be generated in your mind before writing down this particular equation. I don't know whether it is right or wrong. I think it is right. But what I want to say is, when you are finding the Norton's current, you have to keep these things in your mind. So that is why in first class we will not tell that. So this is the Norton's current, short circuited, this capacitance gets shorted, and this particular between the corresponding the source to parallel connection to this is shorted, and this one. So these two are in series. How these two are in series? Because there is a short circuit here, zero resistance. So then the current flowing through this PQ can be obtained as applying the current division rule. So current, total current multiplied by opposite parallel branch resistance 25 ohms divided by some of the 3 resistances that are being there. That is why you may ask me a doubt. That is why I put deliberately that 0, otherwise not necessary. J30, then 15 ohms and minus J50. Instead of that I put 0, and this resistance also 25, because these are the entire J30 ohms, 0 ohms capacitive reactance shorted because 1, and 15 ohms comes from only one branch, parallel branch. These 3 are in series in that sense. Plus this branch also. Opposite resistance by some of the all the 4 elements. In this case, that you have to be cautious. So, but this 4th element is shorted element. So that value is put as 0 deliberately to replace this minus J50 by 0. Because you may ask me why you are not put minus J50, why you have put 0. Because it is shorted. Because of the short circuit only, this and this are 30 ohms and that is inductive reactance and 15 ohms resistance are in series together with this, and so it is parallel branch. So for this 20 ohms parallel branch, all the 3 that is J30 ohms, a short circuit, and 15 ohms are in series. So therefore, this is how we have it. So this parallel resistance branch plus this resistance also should be added. Alright. So I into 25 by J40 plus J30 it happens to be. So it's equal to 8 at an angle minus 36.86. is equal to 6.4 minus j 4.8 is A is the answer. I hope we are able to follow this. So with this, our friend will briefly quickly brush up in 1 minute that today I have started with the network theorems. Although there are 9 theorems, I have discussed. I was able to discuss only 3 theorems. Okay, that is superposition theorem, Thevenin's theorem, and Norton's theorem. With good, very typical examples, I believe. They are complex problems. A fundamental one which our device also explained. The statement of the theorems are already known to you, but where it is applicable, where it is not applicable, and other things are mentioned. So now I would like to proceed to the question and answer session. And tomorrow's class, at the end also I will maybe repeating in the sense, I will be starting with maximum over transfer theorem, and some more theorems will be explained. And I will try to cover the, if for time permits, after 1 or 1.5 hour session, the question and answers where how much we can do it, I will continue with that. I think that is how we will plan, so that no loss of generality will be there, and some topics, some theorems also will be covered. That means although I planned for 4 theorems and tomorrow 5 theorems, today I could get only 3 theorems, and tomorrow how many I can cover, you can see, right? So there will be 6 more theorems. I do not want to delete any of the theorems because everyone is having its own importance. I want to explain them. Okay, only 1 or 2 may not be very significant immediate applications, but all the other theorems are very important, right? So I request Mr. Surendra to just move the slide to the previous this one. Network theorems, network topology. Yeah, I would like to explain the network topology because it is immediate one. Yesterday itself I got it, and 13th session I have to do it. I will try to do it subsequently. Yeah, I'll keep it. So I may use this slide appropriately whenever it is come across. So I will read out the question. Maybe you may not be knowing that. So try to understand carefully. If you want to note down, you can note down slowly. I don't use for every query or question and answer question, I may use the slides. Wherever it is absolute necessary only, I will be using the slides. Okay? Because some are based on the problem that is being solved. Okay? So one question that is being asked. Who has asked is material here? Okay? Explain the difference between a self loop and a loop of a circuit. Okay? So a self loop is the one which is starting from the same node and reaching to the same node. Starting and end vertex is same. But whereas a closed loop is a traversal, a circuit is a traversal. A self loop, even in control systems, self loops, Mason's gain formula, in that self loops are being present. A particular element which starts from that, originates from that, and then leaving from the same thing is called the self loop. Okay, self loop have got no significance, I said, therefore it should not be get confused with a loop or a circuit. Okay, self loop is the one, an element is originating from the same node and reaching to the same node itself, which has no issues for solving the problems. So we have to eliminate them. How to solve problems related to cut set and tie set with examples? Please explain with examples. Already I have done that, but anyway, I will briefly explain this based on the slides. Already I have explained this. Maybe first few minutes people might have got confused. Now I can explain that. Yeah. So cut set by definition is a minimal set of edges whose removal from the graph isolates at least one vertex. So this is the with respect to a spanning tree that has been obtained. Okay. Sometimes where the cursor is going, I will not. Now I'm getting. Sometimes I will not be able to see this. That is the biggest problem. With other color it is fine, but you did not want this. But I am comfortable with this. Please bear with me. Somebody asked me to eliminate this blue background, but I can see this cursor in this projector. Okay. Anyway, please bear with me for today for this, because whatever the reasons. So this is the original circuit. This is original circuit, and this is the corresponding graph that is being drawn in the previous class. And this is the corresponding spanning tree that has been considered for identifying cut sets. So it is a spanning tree 1, 2, 5, or even here also 1, 2, 5 or 1, 5, 2. Okay. So the cut set elements are this. This is one of the examples. So 1, 3, and 6 is a cut set element linking with one branch and two links, and 3 is the corresponding link. 4 is the link. 6 is the link. So these are the independent set also. Somebody has asked that also. Okay. So this is the core elements. Complement of the tree. That means that is why we have shown in dotted lines and thick lines. Thick lines is branches or twigs. Okay. Tree, core tree, and branch twigs. From the tree, the elements of the tree are called twigs. They are also called branches. Okay. So 1, 2, 5 are branches, 3, 4 are strings or links. Each link is one question is being answered that is also pointed out by someone. That is, what is an independent set of loops? With 3, I can write one loop equation among the elements 1, 3, 5. Do not confuse that how the voltage sources, dependent sources, and other things are being there. There as it is. Only element graph is being drawn. Okay. Element is being drawn. Whether it's dependent source or element resistance or inductance or capacitance, nobody has stated. But this is being represented as a graph. So that how many loop equations are required? 3 loop equations, because there are only 3 links in this. Although there are 6 elements that have been shown in the graph. Actually, in the circuit, there are 2 voltage sources and 6 elements. For finding the current through each element, maybe one may be tempted to say that I need 8 equations simply because there are 8 elements in the network. Okay. So, but here I require to know only 3 loop equations and 3 nodal equations, because node pair voltages are also 3. Okay. Because there are only the number of elements in the branches are only 3. So some of the questions are related to this. Okay. So if you follow all these statements carefully, 3 or 4 answers would have been there in this particular one. So this is core tree. This is tree. The elements of the core tree are called links. Tree plus core tree is the complete graph. Right? This is the complete graph. This is the graph of the, from this network, for this network, this is the graph. So for this network, this is the graph. So like that. So therefore, that is the explanation for this. So how to solve the problem related to cut set and side set with the another one, maybe what is your mind is, I do not want to solve this. Die set and cut set problems with examples means maybe you wanted to get the cut set and die set matrices. It will be repetitive if I do it in power systems or somebody who teaches in power systems. It is too early to understand this at this point because already are more matured. I don't want to repeat that because there is slightly sign convention differences in circuit theory and power system applications. I told you that at the initial remarks. Maybe it is difficult to remember every sentence, but this can be studied more in depth with respect to the matrices ABC, element node incidence matrix, bus incidence matrix, basic cut set incidence matrix, basic loop incidence matrix of ABC. Okay. In subsequently in power system analysis, first graph theory is first chapter, and that is that only based on this particular one. But this is applicable even in electrical circuits also. This is the basis. One person has asked why graph theory is chosen as method. No, I have not stated that it is a method. It is only gives an idea about how many number of equations are required to solve the problem using loop current method. That is number of links. It is equal to number of links. Although there are 8 elements in the network, I need only 3 equations required. 3 independent equations only I need. And I need only 3 nodal voltage equations for nodal analysis. So in maybe day of tomorrow's class, I will be able to explain loop current and nodal analysis. They are also treated as network theorems to my surprise. It is based on, loop current is based on Maxwell's circulating current. Only day before yesterday I saw in some textbook that is being defined as Maxwell's circulating current theorem. That is called loop current method. We should treat that as method. And similarly, Kirchhoff's voltage law is Kirchhoff's node voltage theorem. So these two are new terminology for me. So, but loop current and nodal voltage, we thought they are methods, but they are based on the theorems. That is based on KCL theorem and KVL theorems. They are also treated. So Maxwell's loop current, circulating current method is loop current method, which I will be discussing day of tomorrow. These are not only methods, they are required to be understood for solving the problems. So 9 theorems plus loop current and nodal analysis are absolute necessary for solving any problems. Right? So in a graph, next question. Anyway, one question that is being asked is, which is the textbook for topology? I have already mentioned, maybe you have missed that. You can note down that graph theory with applications to engineering and computer science by Nursing Dev, N. Dev, DEO, Dev. Okay. So there is a graph theory with applications to engineering and computer science, and Prentice Hall of India publications. It was published in middle of 80s. Okay, and I told you that I have got the privilege of attending to his expert in IIT Delhi. I don't know whether you mentioned, listened that particular one or not, but doesn't matter. Just only he is like a guru to me because I attended to his lecture. So, right? So that is why I am telling that, not to say that anything has no relevance to what I have done my PhD in that area. Yeah. Okay. So, textbook is Graph Theory with Applications to Engineering and Computer Science by Nursing Dev or N. Dev, which is very popular in now computer science field. But I always repeat, graph theory is originated from electrical engineering problems only for solving the basic loop current and nodal equations. For understanding this, we need to understand graph theory problems. And later, I also told some more applications of reliability engineering and other things. They represent directly the failure modes and other things that is beyond the scope here. So, next question. In a graph, sources are changed with internal resistance, but dependent sources, now they are how they are taken as short circuit or open circuit. This is a very good question, and later only I understood the importance of this one. And independent or independent source only are to be replaced. Dependent sources cannot be replaced. They have to be retained as it is. That is where I have mentioned in Thevenin's theorem and Norton's theorem also. Okay, they have to be replaced as it is because they are dependent. Okay, how they are dependent, what the nature, those things. If such a situation occurs, how we have to solve the problems. That is how we do that. So, right. Then, in duality, how inductance and capacitance came across the current source. Yeah, this I will explain briefly again. Yeah. So this is the corresponding one. Maybe from this circuit, these synonymous circuits are being given in the sense this circuit and this circuit have got some properties. They are called dual properties. But then how we have drawn this is based on this particular one. If you listen, already I have explained dual properties, but from the circuit and this diagram I can explain. Same, both earlier I have shown the dual network. Now the procedure I have given, right? So this is place the dot outside the network is as datum. Okay, so this pointer is visible to me. Earlier the pointer is not visible, so therefore the blue color is coming up. Without that also I can do, but sometimes this is not visible. Okay, when I am moving, right? Okay, so now it is visible to me. And so place the dot, again it is moving out. So I will use only, sorry, don't mistake me. So this is place the dot at the outside the circuit and place the node corresponding to the loop. There is only one loop, so place only one node. Now for each node you traverse like this from node to this capacitance to node. So this capacitance will be changed to inductance. What are the equivalent values? There are problems in this also because not many times the problems are being asked. That is a topic by itself. I need another 1 or 2 hours for explaining this particular one. How to calculate the dual network elements, equivalent values, and other things. But the properties of the elements are that because of the nature of the equations, you can see the characteristic and the basic equation, mathematical expression is same. The mathematical expression is same. You can see, right? This equation resembles. Mathematically, there is no difference. Source. This is called integral differential equation that I have already explained. So therefore, I don't want to take much time on this. And so C gets transformed to as a dual element as L, and then L gets transformed to C. Maybe I have not written in that order, but I have named them, numbered them correctly. This C capacitance gets transformed to L dash. L gets transformed to C dash. That's what. Okay. L gets transformed to C dash. So this is C is not the capacitance. ABCD traverse also I mentioned. So this is the explanation. Okay. Right. Next question. I hope you are able to follow. So what is the difference between tree, co-tree, cut set? Explain some sample example. I already mentioned. So while explaining the another question, I already mentioned this. I hope it is clear to you. Yeah, this is a critical question. I made a mistake in this. So I will tell you that. A very good, genuine question is being given. Page number 11, question number 6. Page number 11, question number 6. Yeah. Here, it is a question that is confusing. I repeat the statement of the problem here. The number of independent loops for a network with n nodes and b branches is n minus 1, b minus n, b minus n plus 1. Not that. Similar to that here. Yeah, sorry, 6. Sorry. Yeah, this question. A network has 7 nodes and 5 independent loops. The number of branches in the network is, the answer I have given is 11, but somebody has pointed out that they are getting 3 because I have written wrongly here. Explanation is given correctly, I will tell you. While writing down here, I have written wrongly. That is the only mistake. So, in the sense, this expression, the asked question is the number of given nodes, given 5 independent loops, the nodes here, okay, the branches. I mentioned these branches should not be mixed with the definition of the tree branches. They are considered to be elements only. That is what I said, it is not standardized. Okay, so based on the question, you have to imagine that they are the elements. That is why elements I have put branches. Okay, here n is equal to 7. So branches means total number of elements here for this question. Why? Because they kept that idea in mind and then they are treated elements as branches. Okay. So independent loops means links 5. So by formula nodes minus 1 plus links, because nodes minus 1 is number of branches, number of tree branches. So branches plus links is equal to total elements. So this is 7 minus 1 plus 5. Sorry for the mistake. The minus and plus signs are to be interchanged. So this formula is correct. So substituting that you will get 7 plus 1 minus, 7 plus 5 minus 1 is equal to 11, but not 7 minus 5 plus 1. Anyway, it is not the choice there, but that is, thank you for giving me that, because that is a question today morning. Even I could get that Google form continuously through laptop only, okay, through my email ID. So therefore, I told you, I can give you my email ID only at the end of the last sessions, and not today because I told you the reason for that also. Explain about source transformation, already done several times, and this also explained what is the difference between voltage, potential difference, and EMF. I explained keeping that in mind in today's lecture. Still, you have got something in mind, again you can find out, but time will not be sufficient. Keep on repeating the things, okay? And cut set problem is to be explained again. I have done it. Yeah. There is a very good question is being asked. Cut set problem 3 to be explained again. I think I have done it. Yeah. This is a critical problem. I understand. I even yeah, this is very critical. Yeah, same in a similar line. Somebody else also asked how the question asked is how 124, 134 they will be cut sets. There are cut sets, but not fundamental cut sets. There is another one. Okay. In this question, somebody else has asked 124 are cut sets. So the total number of cut sets is 2 power n minus 2 can be there at most. It's not that there are cut sets of the graph, cut sets of the node, and if you identify one of them. So what I meant to say here is, for this particular vertex under consideration, 1, 2 is a cut set, and 1, 2, 4 also is a cut set. In the sense, this node and this node are getting isolated if 1, 2, 4 are being deleted. If 1, 2 is deleted, only this node. 1, 2, 4 is deleted this. I mentioned in the earlier problem, it's very critical, right? In the earlier, no, not okay. In this, suppose 136 is a cut set, right? Basic cut set. But you have got other cut sets also. 345 is another cut set. 345, right? And 1546 is another cut set. Like that, there can be any number. You will not be able to. And there are totally 2 power n minus 2 cut sets will be there. The fundamental cut sets only will be with respect to the tree branch. That is one of the fundamental definitions. The number of tree branches equal to number of fundamental cut sets equal to number of node pair voltage equations. That theory is being evolved by only graph theory. So for solving circuit problems, how it is related because of this. It is not a method. It is only a process of identification of how many minimum number of equations are required for solving the problem. So if more than one element is shown for a cut set problem, if 2 elements are sufficient for the cut set to be identified, if one more element is also taken out, that becomes a superset. So that is not minimal. So only minimal elements are required for solving this problem. But another interesting typical question that is being asked is very critical, which I try to solve now. I will explain that in the last question. That's very critical. Okay, there are some more. I will explain that. Okay, this GATE 2004 question or last. Yeah, this question I think. Yeah. So here I have the answer as solution is being given, but I try to give the explanation. True, there are only this question. The question that is being asked is how as a tree and co-tree as 2, all those things are typical to the explanation. But here, this question, somebody asked in the following graph, the number of trees and the number of cut sets are, how many are there? We have justified. And while justifying that, I have given this. These are the number of trees, no doubt. So, from the number of trees, you should get number of basic cut sets only. The cut sets are more. That is why I told you, the cut sets are can be generated in the cut set. These 2 nodes are isolated, these 3 nodes are isolated. So this is another cut set, but may not be. That means it is a combination of, for this particular one, it is more than one node also is cutting. So therefore, it is not related to only one vertex. That is, I have related that to one vertex only. If with respect to one vertex, if it is failed, if the 2 elements are sufficient, why you give 3 elements? That is not necessary because it becomes superset. For example, you know, in Boolean sense, X is a set, Y is another set, which is X plus XY is same as X. So in that problem, because it is a combinatorial problem, if you want to solve a problem for cut set, there will be 2 power n minus 2. Right? So that is beyond the scope here for you at this level to understand. But anyway, it's a very good genuine question is being asked, and that has led to so many problems which I tried to solve because I got some exposure in this even in my PhD area. So although I given here, actually that there are 4 order cutting. So that means when there are 4 elements, they will take all one at a time, then one each at a time. That is by failing 1, 2, 3, 4 individually. No cut, it doesn't make any cut because there will be a traversal that is being present, right? That is well known. Suppose I take out only one. By taking 1, 2 as combination, some of the vertices are eliminated. So 1, 2 is a cut set. So 1, 3 is cut set of this. 1, 3 is a cut set of this. 1, 2 is a cut set of this. And like that, these are the cut sets. Then similarly 3, 4. If you remove 3, 4, 3, 4 is a cut set of this vertex. And 2, 4 is a cut set of this vertex. But what about the other combinations? There is a combination called 1, 4. So 4 C2 combinations you can take. 4 C2 is 6 combinations are there. So out of those 6, 4 C2, 1, 4. If you take out 1, 4, there is a connection between these 2 nodes through the element 3. So it is not a cut set. So therefore, 1, 4 is not identified as a cut set. So similarly, 2, 3. 2, 3 has not been shown here. Although there are 6 possible combinations. 2, 3 is not being shown here because 2, 3 By cutting off 2, 3 from the combinations, it doesn't lead. Suppose you remove 2, 3, 4 is present and 1 is also present. So they don't lead to the cut sets. Right? So therefore, and yeah. So if the circuit is not being isolated with at least one vertex, then it cannot be deducted cut set. Now there are some more combinations that have been given. This is where I said 1, 2 is a superset of 1, 2, 4. But here it is from the total cut sets that is being asked. They are not asked only with respect to basic cut sets, perhaps. That is what we have to assume. Okay. Now I have written 4 combinations now, because taking 3 elements at a time, there are 4 combinations of 1, 2, 3, 1, 2, 4, 1, 3, 4, and 2, 3, 4. Okay. So out of which a few combinations are only the cut sets. Right. So that is the explanation for this. You can say even you delete all the 4 elements, 1, 2, 3, 4. It also needs to a cut set, no doubt. But it will not be minimal. It is not related to the spanning tree or otherwise. If you remove all the 4 elements in the graph, all the 4 vertices are isolated. That is not the solution. Okay. Some more, the subset of it, there is a fundamental definition of this is any other subset of it should not be another cut set. That is a fundamental property. And it may be sometimes possible that if 2 cut sets are there, 1, 3 and 2, 4, then 1, 2, 3, 4 is the disjoint union of the cut sets. These are fundamental theories which is beyond the scope to probably sometimes to understand unless you are read the subject once again. Okay, follow the textbook Nursing Dev for all these definitions and other things. Okay. Even I have written a book on this, and in system reliability concept, these fundamental concepts are being given. Anyway, that's beyond scope for me. Okay. In 2015, it is being published in system reliability concepts, where I need to work out the problems on concepts. Anyway, okay. Then and the question that is being asked is ring coupling are independent sets. That is already being explained. Okay. Similarly, if anybody asks similarly with respect to branches also, but I don't know. Okay. So next question is, please explain the 4th problem. Always repeating the question, maybe unless there is a wrong or something you have identified. Same. Not the 4th question also. So anyway, before showing the PPT, I can explain. Yeah. 4th question. Network topology. Yeah. 4th problem. Yeah. Yeah, this I already explained. Okay. Link related to that. Okay. And in page 2, number of trees for a graph is n power n minus 2. That is true. It is uppermost. It's not that total number of trees only shown to be n minus 1. These are basic elements that are there in the spanning tree, which will be equal to nc n minus 1. I told which will be equal to n minus 1 only. So do not get confused with respect to this. That is the uppermost one. For all the n vertices, for each vertex there will be n minus 1 elements. So a completely connected graph. For every node there is n minus 1 elements that are connected to all other nodes. Then you will have for every node you can draw a tree. So which is n raised to the power n minus 1 elements, like that. The derivation goes and the total n power n minus 2. Follow Nursing Dev. Okay. And because it is n power n minus 1, for every element there will be element between A and B vertex and same as B and A. So maybe half of that. So therefore you will get n power n minus 2. So that is the derivation. Let us not bother about it. 4th is complement of tree. That is being asked also, that I have explained. So why electric circuit is used graph method? It is not that electric circuit theory takes as the basis of the solving the problems. It is not a method. Graph theory is only a solution strategy of how many number of equations to solve. I have already mentioned. If the loop equations are number of loop or node equations. You said A into A transpose. Yes, it is correct. Number of trees can be obtained. Somebody has asked. The determinant of A into A transpose is correct. It is there, formula is there, but that is no significance here, because the topic is related to not the how many number of trees will be there. The problem related to how many number of basic fundamental circuits or basic or fundamental loops are required to be solved for a solving a particular problem. Basic rules are going to be solved using KVL. Basic nodal analysis is going to be obtained using KCL. So those things will be explained in day of tomorrow's class using KCL, and that is Maxwell's circulating current theorem and Maxwell's node voltage analysis. So I think this is the explanation for these things. So in the next 2 minutes, I am going to wind up. Yeah. So this is all about maybe I don't know whether you are able to follow these things or not, but because I took half an hour time nearly to cover the question and answers for the 4th day session. Today we have discussed some theorems. So although there are 9 theorems, I would cover only 3 theorems. Remaining I will try to start from the next one, maximum power transfer theorem, in tomorrow's class. And I have to inform you that all the 4 lecture schedules, lecture videos, or including the PPTs, have been put in the website yesterday evening itself. I hope you might have seen. And any questions today will be tried to answer in subsequently. So it may take 2 more days for explaining the theorems, and assuming KCL and KVL, that is loop current method and node voltage analysis, also has theorems. So some more theorems I need to give examples for that. Very critical. Heart of electrical engineering subject is electrical circuits, and heart of the electrical circuits is network theorems. I always say that. So it's very important. Then only we can go for the subsequent ones. So it is only 5th day. We have got 7 more days, and I would like to cover maximum up to the 6 days. And 12th day, I want to see whether I can cover next lesson. Again, if not covered, various specific points which I can do it, I will try to do for 1 hour and question and answers on the last day. Okay. Otherwise, full session will be for question and answer. But if I say only question and answer, some topics will be missed. So I will spend 1 hour for question and answer on the last day, and 1 hour for the last topic, for brushing up or otherwise. So because good number of questions are being asked, that too comments I have eliminated. 50 to 70 responses are there. Trying to write down those things through that one, writing down, because in order to explain, I need maybe circuit is required, where I have done mistake, all those things need to be verified. And so I need another 2-3 hours time for preparing those things for answering your questions. So good. I appreciate all your interest, and I acknowledge all the people as usual, Honorable Vice Chancellor and DAP and his team, and for giving me an opportunity, and our State Council of Higher Education Chairman, who is our colleague for same generality, for giving this opportunity for me to explain through online gate coaching classes, which is I have chosen electrical circuit and offered to me. So I'm happy to deal this subject, which is very fundamental. And I thank Dr. Bharat and Mr. Surendra for making all the efforts for making this internet connectivity and even cam scanner, these things and other things. And all the team members who are giving the internet connectivity, Google Meet, making this available for internet connectivity. Sometimes there may be disturbance, small disturbance are there for internet flow connectivity. So therefore, 5 minutes disturbance is there. Otherwise, we are happy that full sessions are being completely being made available with no interruption of the basic power supply. Because any power supply is there, we are going to be blamed. We means including the future electrical engineers, because we have to maintain the power supply in right way. You cannot blame others. You have to take the responsibility, shoulder the responsibility of getting the power supply without interruptions. That is a future trend. There's no doubt about it. So anyway, otherwise people will say we are failing in the giving the full power supply at the appropriate times. So as power system engineers, future power system engineers, you have to take that responsibility. Okay. It's not always commenting on others. You should shoulder the responsibility of maintaining the power supply for that, because the electrical engineers only have to do that. With other sophisticated equipment, other these things, accessories are required. Even okay, for applications part, for job orientation, people might do separate professionals. That is a different issue. So I thank all the students who are really actively participating. Even minute details they have been following, giving me suggestions to improve my presentation through PowerPoint and other things. So thank you very much. Thank you one and all. So I am closing the session. Thank you very much.